Okay, so wait. So still less number of people are there. I think so. People are not curious about their midterm exam. So let us discuss about the midterm exam that from it has been postponed so far, and it will be rescheduled after the Diwali break probably. Okay, and as far as the structure of the midterm exam is concerned, it will have a MCQ type questions as per the direction. There will be 40 MCQ questions. The duration will be 1 hour. The 1 hour you have to complete it. Okay, okay, the MCQ type question. So we will be taking some class to get acquainted with what type of MCQ can be there. Now it depends upon the examiner that he should design such type of question so that student should be in a position to do this 40 question in a duration of 60 minutes. So you can imagine that 40 questions are there for for a period of 60 minutes. So one question is for 60 by 40. So you can say it can be 3 by 2. 1.5 minute will be provided to solve you one question. Okay. So now it depends upon the examiner to examiner. For example, I am a cunning examiner, so I know each and every technique. So I know how to fix the time. I know how to fix the duration. Everything in the Google form. Okay. So as far as mine is concerned, everything will be fixed in your so-called the examination Google form paper. It will be through Google form only. Okay, the Google form will be link will be shared, and probably people like me will share online. Also, thing you have to keep in mind, that is, I will not share on the WhatsApp group. I will share on the if I will share on the WhatsApp group also, then also everything will be fixed from my point of view. However, those who do not know the technique, then they may allow you the time and you can solve at your own. Okay, so this is all about the pattern of the examination, and marks will be automatically will be given because it is in a Google form. There is a option of quiz, so it will be in the quiz form only, and you will not be shown the marks. I will be having all the marks. Then later on, whenever the college will say, we will display that mark. So now, any question so far regarding the structure of the midterm exam? Okay, so one by one, you can raise the hand, and I can just take your question. Okay, I can just Akash Shoni. First of all, Akash Shoni, do you have any problem? I'm just Akash.
No, sir.
No, okay. Amit Paliwal.
No, sir.
Divyanshu Joshi. Divyanshu Joshi has a problem.
सर नंबर ऑफ क्वेश्चन सर इससे कैसे बन पाएंगे सर, मतलब 40 क्वेश्चन ज्यादा नहीं हो जाएंगे सर?
These are the instructions from the COE. These are not my instructions. They have said that yes, you have to design 40 questions and 40 questions.
और सर ऑनलाइन होंगे सर? पक्का सर ऑनलाइन होंगे या ऑफलाइन भी हो सकता है?
Depends upon people to people how people know the technique. I know each and every technique of the online. Okay, you know. Okay, so those who have joined my solar awareness that webinar, they might be knowing that I have circulated the feedback form online, not on WhatsApp group. So
Yes,
only
sir.
few people who have continuously joined and remain at the last are able to get the certificate. You know, Devanshu. Okay. I have the complete idea that how to take, how to judge it. Okay. Those who do not know, then they can provide you relaxation also. Eva Sharma, do you have any question? Okay, no problem. Harshita Dalawat. Okay, no problem. Okay. Hitesh Rathod. Hmm. Hitesh Rathod, we are not getting your voice. Still not? So do check your speaker and everything because we are not getting your voice. Kajal covered Jadon.
No problem, sir.
Okay, no problem. Very good. Kirti Verma. No issues. Okay, fine. Shreyash. Shreyash.
Sir, sir, I have written the
Yes, speak. Yes. Yes, I'm not
yes,
getting.
sir. Repeat कर दूं sir आवाज? Sir,
Okay,
voice
you're
proper नहीं
between.
आएगी sir in chat box. Yes,
Yeah,
sir.
yeah. You're audible. You're audible. But I'm not get your chat box response. Okay.
Sir,
So
I have
now you're
joined
yes,
late,
you
sir.
are audible.
Sir,
So
I
I was
joined
talking
late, sir.
about.
Yes, sir.
Okay, so I was talking about the midterm exam pattern structure. Till it has been postponed, but as far as structure is concerned, whenever it will happen, probably after the Diwali break. So there will be, it will be through Google form, okay, and there will be 40 questions, MCQ type questions. Then you have to give the answers, and those who are very well versed with the Google forms, then they can put it in a very good manner. They can give you in the online form also through Cisco WebEx Medium, either putting that link in the chat box. Chat box में आपको link provide कर मेरे जैसा जो कनिंग होगा वो क्या करेगा chat box में आपको लिंक दे देगा तो अटेंडेंस भी हो जाएगी और वो लिंक इस प्रकार का होगा कि उसमें टाइम और ड्यूरेशन सारा फिक्स होगा तो जैसे ही टाइम खत्म होगा ड्यूरेशन खत्म होगी आपका वो गूगल फॉर्म रिस्पॉन्स करना बंद कर देगा सो यू हैव टू बी वेरी कॉन्शियस बिकॉज टाइम अलॉटेड इज ओनली 1 hour then there can be some person who are not well versed with Google form that they can allow you the uh, much time they can put it on the WhatsApp also everything in my case everything will be in the Cisco WebEx system okay and it will check your attendance also at present I am seeing only 16 participants so though the strength is 68 so all this will be taken into account.
Sir,
After Diwali
exam
break,
वो
still I can't say
Diwali.
because we assume that
Okay.
we can after Diwali break only that is I've already circulated one order of Diwali break from
Yes, sir.
13
Yes.
to 21st January. Sorry, from
Yes,
13
sir.
to 21st November. Okay, I think so
Yes,
it
sir.
is clear.
Yes, sir.
Okay. So anybody anybody more doubt regarding this? Sudhanshu, do you have any problem? No. Tanmay Mishra?
Sir, I've written it out in the chat box.
Okay, so Tanmay Mishra is asking what will be the total syllabus for the rescheduled midterm exam. No worry, whatever I cover, this depend upon teacher to teacher, but probably midterm is generally being covering the syllabus of unit 1 and unit 2. Okay, but as far as mine is concerned, whatever I have taught will be the syllabus of the midterm exam. Okay, and probably it will cover your 2 units. Okay, I think so, Mishra, you are satisfied with my answer? Okay. Yes.
Yes, sir.
This is Kanpur person, Vimal Yash Srivastav. You have any problem?
No problem, sir.
No problem? No problem?
No, sir.
Okay, fine. Yashi Agarwal.
Sir.
No problem? Okay. So, all the still one participant has left. So, this is the situation. So, let us start with the today's lecture. Today's lecture will be related to steady state error. Okay. So, what we have learned so far, we have learned for the behavior of the second order system. Okay. How the standard or prototype second order system has behaved. Okay. During this behavior, if you find that we have come across some data like maximum overshoot, delay time, rise time, settling time. Then there was another parameter that was called the steady state error. We haven't learned about the steady state error. Now, this is a very important topic in your control system. Okay, what steady state error is. Now, when you apply any input, you want a desired output. Whenever you apply, you just switch on the supply of any appliances. You want that the appliances should run in a proper manner. For example, you take fan. So when you switch on the supply to switch, okay, you want that my fan should rotate, okay, at a particular speed so that you can have a comfort, cooling comfort. Now, if it is running slowly, then you are dissatisfied, you are in discomfortable form. So you always want that whatever input I give, you should get the desired output. And if you are not getting the desired output or there is a deviation from the desired output is there, then the difference between the desired output and the actual output is called the error. And this error is not instantaneous error. This error is taken when the system has finally settles down. So that is why we called it as a steady state error. Mind it? We are talking about the steady state error. Steady state error means the error which is there in the system. Okay, when the system has finally settles down to a steady state value. Okay, so basically it is suppose desired value is suppose y desired is suppose yd, and this is the actual output y actual. Then y desired minus y actual is the steady state error, and that also in the steady state condition, not in between the transient. So you will look towards this graph. I'm not talking about here. I'm not talking about here. I'm not talking about error here. Error definitely is there. This is my desired. 1 is my desired value. Okay, you can see this 1 is my desired. ये जो 1 है ना, ये 1 की लाइन, ये मेरी डिजायर्ड है. मैं चाहता हूं कि मेरा सिस्टम 1 पे आ जाए वापस. ठीक है, लेकिन देखिए यहाँ ओवरशूट कर गया, यहाँ अंडरशूट कर गया, नीचे चला गया 1 से. ठीक है, यहाँ फिर ओवरशूट कर गया, इससे कम था लेकिन कर गया. आखिर में क्या होगा कि सिस्टम एक फाइनल वैल्यू पे सेट हो जाएगा. लेकिन फिर भी मतलब coming into steady state value means that system will attain a final value. Now this final value says this is the final value. Okay, now there is a difference between final value and this the desired output 1. Okay, there is always a difference is there. Okay, so that difference can be upward direction, can be in the lower direction. So that difference is called the steady state error. So the deviation from the desired value is called as an at the steady state condition is called a steady state error, and it is represented symbolically by ESS. Symbolically, it is represented by ESS, small ESS, and is being termed as a steady state error. So our next, all the slides will be covering the total structures related to the steady state error. So let us move. What is the other steady state error? Okay, so in order to find out the steady state error, let us find out some basic mathematical analysis of the steady state error. Now, you have this type of system. As you know, this is a closed loop system with a feed forward transfer function, GS, okay, and a feedback transfer function, HS. This is RS and this is YS. Okay, so you can assume it to be a unity feedback system for convenience purpose. So your error, now this, there comes the ET. It is not UT, it is in fact ET, it should be ET. So your ET is ET is nothing but reference signal minus YT. So this is here, sorry, the steady state error comes here, the reference signal minus ET. Okay, and steady state error is defined as limit t tends to infinity ET. So error is reference signal. Reference signal is what? RT. Reference signal is your RT. RT error is being defined as RT minus YT. If in the book or in the anywhere it is YT is being written as CT, then it will be, or it can be also written as, find it, RT minus CT. RT minus CT. Okay, this is the definition of error. This is the definition of error. Okay, reference signal minus CT is, or reference signal minus YT. RT minus YT is the error. Now I am talking about steady state error. So for the steady state error, what happens? You apply a limit t tends to infinity. That is, when the system will settles down to a final value, then what should be its value? So you will find that RT minus CT, you apply limit, so it will be limit t tends to infinity ET, or limit t tends to infinity RT minus CT, or RT minus YT, whatever you can. Since I have used YT here, so don't get confused. It can be CT, it can be YT, depends upon the author. Some people, some author may write it YT, some may write it CT. And suppose if HS is equal to 1, then error is nothing but RT minus YT is equal to UT. So you will get this. If this is 1, then you will get this UT, because this signal is your UT. Okay, so RT is this much, this is 1. So YT multiply by 1, you will get here what? YT. So RT minus YT is this UT signal. Any doubt so far? Please write in the chat box if you haven't understand this. If you haven't understand this, then please write in the chat box. Okay, let's move to, no problem. Okay, fine. Let's move to further. Now, this is a clear picture. What is the basically steady state error? Okay, just don't go through the value of steady state error, but this picture has been shown that now suppose the system is there, definitely this type of response is generally is meant for the second order system. Okay, so in the second order system, you'll find that the system will rises. Okay, it will reach peak overshoot, undershoot, peak overshoot, and finally it settles to a particular value. Now this is your desired value, and this is your actual output. So this difference, as I've already mentioned, this difference is called steady state error value. And in this case, for a step input, for a second order type system, it comes out to be R upon 1 plus Kp. How it has come, that we will discuss later on. But this is the value of the steady state error that you will come to know very soon. Okay, but at present, you can assume that there is some steady state error is there. Though we say that at t tends to infinity, the system will reach to its desired value, but it that happens, and always there is some error is there. Okay, so how much is that error? That error is this much. And now we will go for the mathematical analysis. Previously, we have gone for mathematical analysis in a generalized way, where I have defined the error ET, error steady state error ESS, being defined as limit t tends to infinity ET, and ET is nothing but RT minus YT or RT minus CT. Is it clear? Okay, this is another figure is being shown to you. Okay, there now the input is which type of input? Can anybody can tell me what type of standard input is being applied here? What is the name of this input? Yes, Tanmay Mishra has written very good, correct. Anybody more? If Sharma has right, Kirti Sharma is right. Yes, Shreyash Bora is right. Yes, it is a ramp input. It is a ramp input. A standard signal is there. So whenever we'll talk about the steady state error, we generally apply the standard input. That is the step input, ramp input, and the so-called the parabolic input. So here also you can see this is the input and this is the output. There is a difference between the desired value and there is the actual output. And this in fact comes out to be R upon KV. That is a different thing. The value is different thing, but understand from the graph that whenever you apply a certain standard input, there will be always be some error, and that error is being shown graphically. We will calculate all this error. This is an parabolic input. You can see a parabolic input is there. Later on, you will see that this parabolic input is also known as the acceleration input. That is, a ramp input is called velocity input. Okay. So this is the reference input, the standard input. Again, you can see a steady state error is there for an second order system. Okay, and this error is R upon K. How it is calculated, that is a different thing. But at present, please understand that whenever a standard input is being applied to a second order, first order, or whatever may be, there is always a steady state error. And steady state error means that the error difference between the actual output and the desired output when the system has finally settles down. System पूरा अपने आप में settle हो गया है, उसके बाद उसका जो reference input है, reference signal है और actual output के बीच में कितना difference है, वो क्या कहलाएगा? वो क्या कहलाएगा आपके steady state है. अब हम ये this now comes the role of mathematics. Okay, that is very important. Okay, and you have to remember this all this important formula. So how we start, as I already gave you that steady state error is being defined as limit t tends to infinity et. Okay, so here one assumption has been made, a unity feedback system. So no doubt a unity feedback system is there, but I will give you a generalized formula. Okay, what is the generalized formula? Okay, so you should remember both formulas. Because as soon as you apply HS is equal to 1, okay, you will get these results which I am shown in the slides. जैसे आपको मैं एच एस इक्वल 1 करूंगा, लेकिन ये क्या है, ये जो स्लाइड मैंने आपको बता रहा हूं इसमें मैंने एच एस इक्वल 1 माना गया है. अगर एच एस 1 नहीं है तो ये रिजल्ट कैसे चेंज होगा, मैं वो भी आपको साइड में बताता रहूंगा. ठीक है, तो सबसे पहले हम देखते हैं कि स्टडी स्टेट एरर को मैथमेटिकली कैसे डील करें अलग अलग इनपुट्स के लिए. तो पहले हमने बताया कि स्टडी स्टेट एरर कैसे डिफाइन किया जाता है. लिमिट टी टेंड्स टू इंफिनिटी ईटी. ये डेफिनेशन, एवरीबॉडी एग्रीज विद द डेफिनेशन? आई थिंक सो. दिस आई हैव ऑलरेडी क्लियर. Now I will convert into time domain quantity into S domain, because you know that we are already dealing with the S domain quantity in the complete control system, whether it is mathematical modeling, whether it is response, or even now come the steady state analysis, steady state error analysis. So when I convert it into the Laplace transform, then it will become limit S tends to 0 and ET will become S capital ES. So S term will be there and ES will be there, which is nothing but Laplace transform of ET. Okay. So now what is ES? Basically, now ES you have to calculate it. Okay. So to understand the ES, I will go through you the this following diagram. Okay. Basically, what is ES? ES is in fact I will give you the generalized term of ES. Basically, this is the error. Though it has been wrongly used as US, it should be ES. Now look towards this picture. Okay. What is ES? ES is nothing but RS minus BS. This is BS. Or ES is equal to RS minus, what is BS? HS multiplied by YS. Is it clear? Now, what is, because generally in any question, you will be knowing GS, you will be knowing HS. So you have to express this ES in terms of, okay, in terms of HS and GS. How do you will express? Now, what is YS? What is YS? Can anybody can tell me what is YS? If you look toward the YS, YS is nothing but ES multiplied by GS. So I can write down ES is equal to RS minus HS multiplied by GS into ES. Is there any problem up to so far this mathematical multiplication, this mathematical manipulation? If please write in the chat box, I can explain it further. Please write in the chat box, is there any problem in this mathematical so far? Okay, now you just rearrange it. Okay, fine, fine. Now you rearrange it. So ES will come on this side. So you are left with ES is equal to, when I will rearrange it, you will get RS upon 1 plus ES. Oh, sorry. One plus GSHS. Is this clear? Is this clear? If not, please write in the chat box. Okay. So from now onwards, you have to remember the generalized definition of ES. Error. The generalized definition of the error. What is that? Okay. What is that? So I am writing here, though I have assumed here it is a unity feedback, but what is the generalized definition? You remember that limit S tends to 0. Here it is SES. Okay, so S. What is generalized definition of ES? It is nothing but, yes, can anybody can tell me what is generalized? It is nothing but RS upon 1 plus GS into H. Remember this. This is a formula. This can be assumed to be a formula which we have derived. Okay, that what should be the definition of an error ES, and how to find out the steady state error in Laplace transform form. It is nothing but limit S tends to 0 SES, and ES we have defined as RS upon 1 plus GSHS. Is it clear? If it is clear, then please write down in the chat box. Everybody should write down. All 21 participants should write down. Everybody should write down, yes, it is clear. Then I can only believe that, yes, things are getting clear. Okay. Okay, fine. So do remember, now I have taken in this slide a special case has been taken, assuming HS to be 0. But mind it, this is not the every time case. Every time, every most of the problem you will have some HS value. So what you will do, that, for example, I am here now taking HS is equal to 1. Okay. So definitely SRS 1 plus GS and HS is 1. So, but what happens that when you will apply for other function, other problems which have HS as some value, then you will always associate HS with GS. So it will become GSHS, 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 GSHS in every formula. Okay, so it was just a special case has been taken. So now you have got this formula that steady state error is defined at limit S tends to 0, SRS 1 plus GS HS. Okay. Now the question arises, sir, how to, we will find out the steady state error for different standard input. Okay. What is that standard inputs are there? So for your convenience, I am writing HS also, okay, so that it not get confused. Now a step input is being applied. Okay, now step input is how much? What is the step input value? RS, R upon S. Okay, let R will be the amplitude. It is not a unity feedback. Let it be some value R, constant value. So R upon S. So steady state error will be nothing but limit S tends to 0, R 1 plus GS. Okay, so what happens? Or 1 plus GS HS. In fact, it should be 1 plus GS HS. Okay, in a generalized form. So what I will do, I will place the value, this S will multiply with both. Okay, when I will substitute RS is R upon S, S plus S, GS, HS, or since when I apply the limit, this S will become 0. So I am left with RS upon limit S tends to 0, S, GS, HS. If it is a non-unity feedback system like this. So, oh, sorry. Sorry. This is the step input. So R upon S. So okay, there was S of this formula also. So RR will cancel and you are left with R upon 1 plus limit S tends to 0 GS. So remember this as a formula. This is not a formula to cram but to understand. How we obtain SS of this cancel? Now next take ramp input. What is the ramp input? R upon S square. So steady state error is nothing but limit S tends to 0 R upon. So when you multiply S square, okay, SS will cancel. You are left with S. So S plus SGS. Okay. When you apply the limit, this S will go. Okay. And you are left with R upon limit S tends to 0 SGS HS. Similarly, when you apply a parabolic input as a Laplace transform R upon S cube. So when you apply R upon S cube, one SS will cancel, left is S square, get multiply with it. So when you apply the limit, this S will go and you are left with R upon limit S tends to 0, S square GS. And in generalized form, you can add an HS also. So these are the three basic formulas for the steady state error for the three standard signal: step input, ramp input, and parabolic input. So you have to remember by heart these three formulas, because as and when MCQs questions are being asked in the various competitive exam, that for example, this is the input, what is the steady state error value? Now we'll further analyze this. Now come, is clear? Now come another concept called type. Definitely you will ask, what is this type? Order, everybody knows the definition of order. Is that, do you know the definition of the order? Highest degree, very correct. Now here we will talk about the another word called type. Okay, highest degree is no doubt is the order, but now we will talk about the type. This is very important in steady state error analysis. Type is defined as the type is first of all order is defined for closed loop transfer function CS upon RS or YS upon RS, whatever you can call it. It's a closed loop. So order is always being defined for closed loop transfer function. You have to completely find out the closed loop transfer function for a system that is GS upon 1 plus GSHS. But type is being found out by another word, by another transfer function, which is called open loop transfer function. Now, what is this open loop? Open loop transfer function is defined as GS multiplied by GS multiplied by HS. This is being defined as an open loop transfer function. Okay. So from now onwards, if somebody asks you what is open loop transfer function, then you will say so GS for a closed loop system, it is GS HS. What is closed loop transfer function? It is nothing but CS upon RS is equal to 1 plus GS upon 1 plus GSHS. Okay, so do remember these two, not to get confused with open loop transfer function and closed loop transfer function. In steady state error, we are interested in open loop transfer. Mind it. In the steady state error, we are interested in open loop transfer function, but not in the closed loop transfer function. And once you find out the open loop transfer function of any system, we look into the now open loop transfer function. Let it is in this form. Let us just say this is GSHS, because in this slide the author is assuming that everything is unity feedback, but this is not the case. Suppose this is GSHS. Now you got this much of the transfer function system. Okay, so what you will say, suppose you got this much of the transfer function GS upon K upon 1 plus T Z1S plus like this. So some poles are there, some zeros are there. There is a exponential term which is causing delays also there. Now, in order to find out the type of the system, we look into the number of the pole at the origin of an open loop transfer function. Mind it, look, concentrate on my definition. The type of a system is being evaluated first of all from ओपन लूप ट्रांसफर फंक्शन. पहली बात क्लियर हो जानी चाहिए कि जो टाइप है वो किससे निकलेगा, ओपन लूप ट्रांसफर फंक्शन से. दूसरा अब ओपन लूप ट्रांसफर फंक्शन का तो ये है. अब दूसरा में टाइप निकालना है, तो टाइप के लिए हम किस पर ध्यान देंगे, उस ओपन लूप ट्रांसफर फंक्शन में जो पोल्स है, कौन से पोल्स एट द ओरिजिन कितने हैं, पोल्स एट, और नॉट ऑल पोल्स, पोल एट ओरिजिन. ये पोल्स ऑफ द ओरिजिन डिफाइन करेगा सिस्टम का टाइप. मान लो 2 है पोल, तो टाइप कितना हो गया, 2. मान लो 3 पोल है एट द ओरिजिन ऑफ ओपन लूप ट्रांसफर फंक्शन ऑफ ए सिस्टम, देन वी विल हैव टाइप 3. अगर एक भी नहीं है तो हम कहेंगे टाइप 0 सिस्टम. बात समझ में आई? यस, एनी डाउट? Any doubt so far? Please write in the chat box. I can reply it immediately. I can repeat the things. Clear? The type of a system. Type means, first of all, type is being governed by the open loop transfer function. It's governed by open loop transfer function. Secondly, how it is being determined? It is determined by the number of the pole at the origin. Okay, let's take example. Suppose now this K, open loop transfer function of a system is given as K upon 1 plus 0.5 S 1 plus S, like this. So how many poles you are seeing at the origin? Poles, not zeros. Mind it, type is not defined by zeros. It is only solely defined by the poles. And which poles? Poles at the origin. Pole at the origin. So give me, so it is written, it is a type 1 system because this pole, this is a single pole which is lying at the origin. Origin का क्या मतलब हुआ? आपका S plane नहीं होता है, S plane होता है, ठीक है. X axis क्या कहलाती है? Give me the answer in the chat box. What is X axis is called? Everybody is sleeping, I think so. What is x-axis? Real axis, real axis. And what is y-axis is called in S-plane? This is S-plane. Pole and zeros are always defined as S-plane. S-plane has two axes. One is horizontal axis is called real axis, and the vertical axis perpendicular to the real axis is called imaginary axis. We have a positive imaginary and a negative imaginary part. Okay. Now we locate poles and zeros. So here this is the origin. This point is called origin. So in type, we are mostly interested in determining the number of the poles at the origin, the number of the poles at the origin, and that of whom? Kiska? Whom? Kiska? Number of pole of origin of whom? Please write in the chat box. मतलब ये पोल्स किसके होने चाहिए? क्लोज लूप के, ओपन लूप के, या जीएस के, या एचएस के, या किसके? समझ में आया? ये पोल किसके होने चाहिए? किसके होने चाहिए? ऑफ होम? GSHS. Very good. Kirti Verma is written very good. Correct? Yes. GSHS. Not of CS by RS. You did not have to take GS upon 1 plus GS. You have to take GS multiply by HS. आप उस सिस्टम को देखिए, उसका GS कितना है, उसका SS कितना है. जैसे कि मान लो अब ये दिया हुआ है आपको, एक नीचे एक और एग्जांपल मैंने शो करके दिया हुआ है. एक GS HS इसमें यूनिटी मान लिया गया. अब इसका टाइप कितना हुआ? नंबर ऑफ पोल और द ओरिजिन कितने हैं? 3. S cube रिप्रेजेंटिंग हाउ मेनी पोल्स आर लाएंगे. कैसे लाई करेंगे? ये पोल देखो, ये हमारा एस प्लेन है, एक के ऊपर हम बना देते हैं ऐसे ताकि लोगों को दिखे. सॉरी, ये सभी तीनों ओरिजिन पे लाई कर रहे हैं. ठीक है, तो ये बता रहा है कि हाउ मेनी पोल्स आ रहे हैं. या तो आप इनको बड़ी लेंथ से दिखाकर बता सकते हैं, या ये थोड़ा मैंने ऐसे बना दिया, ऐसे एक एक के ऊपर एक ओवरलैप कर रहे हैं. सो 3 poles are lying at the origin. 3 poles are lying at the origin. So type of the system is 3. So type of the system is what? 3. Is it clear? Okay. So because why I am focusing on is later on we will define the steady state error with the help of this only. Now let us take a unity feedback system. Okay, because we have restricted ourselves, though it is true for other system also. Type 0 system. First of all, please write in the chat box, what do you mean by type 0 system? What do you mean by type 0 system? Not order 0. Again wrong. Shresh Bora, you are not following the thing. Type 0 means, yes, Kirti Verma is correct. Kirti Verma is correct. Vimal, yes. Yes. Of whom? No pole at origin of whom? Of open loop transfer function. Pole 0, Akashwani. 0 pole at the origin of open loop transfer function. Very correct. Very correct. So I am taking first of all type 0 system. Now I will find out the so-called the error constant. Now what is this error constant? Let us look towards the formula first of all. These were the 3 formulas I have given you, okay, for step input, for ramp input, and for parabolic input. Okay. So in this step input, okay, this term, step input, this term is called Kp, position constant. What is its value? Limit s tends to 0, gs, hs. If hs is 1, then it is simply gs. So this is known as Kp, the position constant. इसका नाम क्या है इसका? Position constant. Similarly, here in a ramp input, this is called Kv. This is known as velocity constant. क्या कहलाता है ये? Velocity constant. उसी प्रकार लिमिट s tends to 0, s square gs. ये क्या कहलाता है? Ka. क्या कहलाता है? acceleration constant. So Kp, Kv, Ka. You have to remember these three things. Okay. And now you can define what will be the steady state error for a step input for any function. It will be Rs upon 1 plus Kp. What will be the steady state error for a ramp input for any system with input Rs? Then it will be Rs upon Kv. And what will be the parabolic? What will be the steady state error for a parabolic input? It will be R upon Ka. So Kp, Kv, Ka. These are the three. These are known as the error constants. These are known as the, इन तीनों को क्या कहते हैं? Error constant. Okay. So these are known as the error constants. Same error constant concept. So now you can see the step, the Kp, I have already defined you. What is limit h tends to 0, gs, hs. If hs is 1, then it's simply gs and is known as step error constant or position error constant. Mind it, the more frequently word used is the position error constant, not step error. Though in this slide it is written step error, but it is known as Kp, position error constant. Kv is known as velocity error constant, and K is known as acceleration error constant, or some books may write as step, ramp, parabolic, respectively. So for step input, the steady state error is how much? R upon 1 plus Kp, okay, or R upon 1 plus K. Now we will take, now I am taking type 0 system. I am taking what? Type 0 system. So in type 0 system means no pole at the origin. No pole at the origin. So there is no chances of cancellation. So I will simply get a constant value, and for a step input, the steady state error for a type 0 system will be R upon 1 plus K. For a ramp input, now input is ramp, okay. For an input is ramp, we know that what is the value of steady state error in generalized form? Everybody knows it. It is R upon Kv. R upon Kv. Clear? Now here I am applying. Now see, look towards. It is a type 0 system. What it is? A type 0 system. Now you know that Kv is what? Limit SGS. What is Kv? SGS. Now, since it is a type 0 system, in GS there will be no S term, which indicates that there is a pole at the origin. Type 0 means there is no pole at the origin. So there is no cancellation for the S term. So when I apply the limit S tends to 0, okay, this whole will become 0. This whole will become 0. Okay, so R upon 0 means infinity. So for a type 0 system, when I apply a ramp input, the error is very, 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 very large. In fact, uncountable, very, very large. For step input is R upon 1 plus K. For type 0 system, for type 0 system, I apply a ramp input, the error is very, very large. And if I apply a parabolic input, again this will become 0. So R upon 0 is nothing but again an infinity, a very large value. His type 0 systems are not suitable for ramp input or a parabolic input. Mind it. This I want to dictate. The type 0 system means which have a no pole at the origin. Okay, they are not suitable for ramp input and parabolic input because they produce a very large error. Large error means it is a unsatisfactory device, unsatisfactory system. Okay, so they can at most can bear which step input with an error. Step input with error, that error is equal to R upon 1 plus K. Okay, so but they cannot bear the ramp input and parabolic input because they produce a very, 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 very large error. So physically, you understand that a type 0 system is unsuitable for ramp input and parabolic input. Is it clear? Let us take a type 1 system. Now, type 1 system means, please write in the chat box, what do you mean by type 1 system? Type 1 system means there is a one pole at the origin. So your transfer function GS will definitely have 1 upon S, one pole at the origin of GS HS. one pole at the origin of GSHS, mind it. So what about KP? So when I will KP, in KP, there will be term 1 upon, in GS, there will be term 1 upon S. So when I apply limit, it will become infinite. So KP will become infinite. So for a step input, the formula is 1 upon R plus KP. Put here infinity, 1 plus infinity, again infinity, R upon infinity is 0. Okay, what a great. In a type system, if I apply a step input, the steady state error is 0. There is the reference signal and the output signals are same. What a beauty we are getting. Okay, so type system is giving a zero error, a zero steady state error for a step input. But what about ramp input? What about ramp input? Look, what is about ramp input? In ramp input, we have to find out KV. KV is nothing but limit S tends to 0, SGS. No, GS has a 1 upon S terms. So this S and SS will cancel. So definitely we will get certain a constant value KV. And therefore, the ramp input steady state error due to ramp input in a type 1 system will be R upon KV or R upon K or whatever you can. Means there will be some error. There will be some error will be there for ramp input in a type 1 system. Now what about parabolic input K? So one S will cancel, one S will remain there. So it will make the limit this K is equal to 0. So when I substitute R upon K, K is equal to 0, that will become infinity. Hence, the type 1 system parabolic input, the steady state error in a parabol is very, very large. In type 1 system can very beautifully handle step input, give, in fact, the output resembles the input, while the ramp input, there is an error is there, and as we apply the parabolic input, the error became very, 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 very large. Okay. So again, type system has certain constraints. Let's come to the next. Type 2 system. Okay, type 2 system. Okay, now type 2 system means there are two poles at the origin for GSHS, that is for the open loop transfer function. Okay, so KP is equal to limit S tends to 0, GS. What will be KP? Because there is a 1 upon S square will be there. So that will become infinite. KP will become infinite. Definitely the steady state error for a step input will be R upon 1 plus infinity. That will become 0. Okay, what a fine. In type 2 system, again for the step input, we are getting a steady state error 0. That is the reference signal and the desired actual output are in fact coinciding. Then come ramp input. Then we find first of all find out KV. Now in a type 2 system, there will be 1 upon S square term. One SS will cancel, but one that the remaining S will make it infinity. Okay. So when I will substitute R upon infinity, it will become, oh, what a great. You are getting steady state error to step input also 0 and for ramp input also 0 for a type 2 system. What about parabolic input? When you will apply parabolic input, you will find S square will cancel, but you will have some constant value. So it will have R upon K value. So some constant value will be there. But you will surprised to know that as we increase the type of the system, the steady state error for step input and ramp input has made 0. However, still has remained for the parabolic input, some error will be there. So a great conclusion we have found out that for type 0 system, okay, the step input will be there, while for the higher system, for type 1 system, the steady state error due to a step input is 0. Due to ramp input, type 0 system will have a very large error. Type 1 system have a constant value, while type 2 or higher system will have a steady state 0. While for a parabolic input, what you will find that type 0 system will have an infinite or a large error, steady state error. Type 1 system will also stay, but type 2 system will have constant value. And if you take a type 3 or higher system, the steady state error will be 0. So from a steady state point of view, you will always prefer, you will say, sir, we will prefer type 3 system. Is it not? Because steady state error is becoming 0 for both, for all the three inputs, step input, ramp input, and parabolic input. Okay, so this is just a numerical is there. So I will not go through this numerical. So that's all for today, where we have talked about the steady state error. We have talked about the value of the steady state error, its numerical value, its formula. Then we apply for the different type of the system. First of all, we have defined what is type, and then we have applied the steady state, find out the steady state error for the different type of system by applying the three standard inputs. in step input, ramp input, and parabolic input. So any doubts so far? Please let me know so that I can cover within 1 or 2 minutes your doubt. Okay, fine. So that's all for today. So in the next class, we will take some more thing. Yes, definitely I will share.